All right, we are presenting Rethinking Database SpacetimeDB. Our team is Alexandra Akala, Christopher Church, Leslie Herrera, and Roberta Palacios.
So before we jump into SpacetimeDB, let us first take a moment to discuss the traditional database model and its pitfalls. Databases typically operate as standalone systems. Thus, databases require third-party servers in order to handle requests, and clients are forced to rely on middleware in order to interact with the database's data. So this is where SpacetimeDB comes in. SpacetimeDB is a relational database that doubles as a server. This means that application logic is able to be ran within the database itself. SpacetimeDB also uses an in-memory architecture for high-speed performance. Thus, SpacetimeDB is optimized for live service games and real-time apps.
SpacetimeDB modules define schemas and server-side business logic. The modules are structured around relational tables, and as such, we can run SQL queries on them. The modules are written in Rust or C# and compiled to WebAssembly, which is what gives SpacetimeDB its edge in real-time computing. The modules can generate client libraries in multiple languages to expedite the process of working with SpacetimeDB. Reducers are the core interaction model provided to us by SpacetimeDB. Reducers are essentially functions that act as remote procedure calls. These remote procedure calls execute as atomic transactions and must succeed entirely, or any changes they aim to produce must be rolled back. A limitation of this is that we can have no nested reducer calls, otherwise, there may be unexpected behaviors.
SpacetimeDB allows for the use of two SQL subsets. The first is a traditional SQL subset that allows manual data manipulation through the use of queries like insert and delete. It also allows selecting data by its column, which isn't permitted for the other one, the subscription subset, which is a more specialized version that allows retrieving like a real-time view of the table for updating and reading automatically. Because of this, um, like automatic process. It doesn't allow for manual querying like insert or delete. However, given that space-time DB is like row-wise, has like a row-wise nature to it, it has row-level security on how users can access data from each row. However, it doesn't seem to have like a column level security exactly, meaning that if this is required, this might be a limitation.
So unlike traditional database systems, SpacetimeDB handles data migration incrementally, meaning there are no forced updates. Instead, the schema is updated row by row from old tables to new tables as needed. This allows for real-time updates with legacy data getting copied and transformed into the inherited table whenever accessed. SpacetimeDB also uses its own custom command line interface to handle core parts of database management. Authors can publish, delete, rename, and build modules through the CLI, as well as access logs and metadata about these published modules. Authors can also directly invoke reducers to perform actions independent from any client code. And for global access, CLIs are required to publish modules in SpacetimeDB's cloud host service, Maincloud, allowing anyone to connect to the deployed server.
SpacetimeDB provides a lot of the features typically found in SQL databases. However, it improves upon responsiveness in order to provide users with interactive applications. It also focuses on real time computing in order to give developers the control they need for their real time data applications. Unfortunately, it does have a few issues with security, specifically with column security. Despite this, SpacetimeDB is still a platform that merges logic and real time access. Okay, for our demo of SpacetimeDB, we will be playing a simple multiplayer game where you, as a player, collect other circles and grow in size to challenge other players on the screen. Currently playing with me are Metzley and Alexandra, and we should run into them at some point and be able to interact with them. Now, currently, all our interactions are based off of a Maincloud instance of SpacetimeDB, which means that anybody with our client can interact. Our player models are quite responsive to the motions of our cursor, and that enables us to have fairly fruitful multiplayer, real-time multiplayer experiences with other people.